Hello, welcome to Minerals, Rocks, Fossil Talks. I'm your mineralogy teacher, Jen, and it's time for Monday's Mineral. And today we're talking about fluorite, or fluorospar if you prefer. It has a chemical formula of CaF2. Pure fluorite is colorless, which this is pretty close to, but due to impurities, it is often purple, lilac, golden yellow, green, blue, pink, or brown. Like halite, it does have a cubic crystal habit, but it can also be found in nodular and botryoidal forms. Twinning is common on the 111 plane, where it has perfect octahedral cleavage, as shown in this specimen. And hopefully this little diagram here can kind of explain how that cleavage works. So basically you have your cubic fluorite. It's got 6 crystal faces, and then the corners here essentially cleave off and turn it into the octahedron that we see fairly frequently. And since I did mention twinning, here's what a twinned piece of fluorite looks like. These are penetration twins, where they've penetrated each other, grown into each other. Penetration twins are cool. They make such fun little shapes. Fluorite fractures subconchoidally to uneven. This is mostly uneven fracture. It's brittle, so it breaks pretty easy. And it is the defining mineral for number 4 on the Mohs hardness scale. It has a vitreous luster, as you can see from that nice little glassy shine there. Whee! It has a white streak, which I would show you if my streak plate was not also white. I really need to get a dark colored one. When I do, I'll show you. And it is typically transparent to translucent. So what that means is if I hold it up to the light, you can kind of see through it a little bit. Like you can see, sort of, like you can see my finger through it, but it's very, very blurry. So this one is translucent. Now the really fun thing about fluorite is that it is most well known for a special property named after it, fluorescence. My specimens are not great, but I'm still going to try and show you. This one is a little too pure, and so it does not fluoresce. The fluorescence usually happens due to some impurities. This one does fluoresce just a little bit on the top, so I'm going to show you. Okay, so I've got most of my lights off. I've just got the one so that you can see right before. We've got my fluorite. We've got our UV light. Whee! Now, I warn you, it's not great fluorescence, but it will show a little blue. And hopefully one day I will be able to find really good fluorite that actually fluoresces the way that people expect it to fluoresce. So, we'll see how well this turns out. Alright, here we go. Let's see if we can get... It's showing up better on the video than it was. So, there's a little bit of blue fluorescence right on the top. Pull back a little bit. See if you can see. Oh, right there. You see that? Yeah. I had to find the right side, but it does fluoresce a little bit. Okay. Fluorite forms in felsic igneous rocks, typically through hydrothermal activity. It is particularly common in granitic pegmatites. This is from a paper that just kind of shows a bunch of different ways that fluorite can form. I'm not going to go into the details just because I'm not an igneous petrologist, and I don't know that I could dumb it down for me enough to understand all the chemistry involved. because in case I've never mentioned this before, chemistry kicked my butt. And it's a good thing I didn't want to go into igneous rocks because I would have not done well at that. Now, the most common use for fluorite is to make hydrogen fluoride, which is then converted to fluorine. And that fluorine is then added to toothpaste and water to help keep teeth from decaying. So, super useful stuff. Well, thanks for tuning in to today's lesson and learning about fluorite with me. And make sure you tune in tomorrow for some fun fluorite trivia. And I will fossilize you later.